Hello friends, in today's video we're going to be discussing event-driven architecture within .NET. We're going to be seeing how we can actually implement event-driven architecture within our two web APIs as well as a Azure Service Bus to facilitate the communication. We're going to be going through step-by-step of the design behind it and how does it work. Then we're going to be going through the implementation by creating our Service Bus and then creating two web APIs that's going to be utilizing the Service Bus to communicate through events. Before we get started into building this, let's understand why do we need it and how does it work. So let's get started. So what I have here is basically a way where we actually two APIs will communicate. So let's say currently I have API 1 and I have API 2, and if API 1 wants to communicate API 2 directly, what we can do is we can utilize a HTTP request. So let's say here, for example, we have just placed some kind of an order and I want to send an email utilizing my email API. Thank you for placing the order. So what happens here, once API 1 finishes its work, what it can do is basically send a HTTP request to API 2, and then API 2 will communicate with all of the third-party email providers and it will send the emails. But this can, this can cause a lot of problems, because basically what happens if, for example, API 2 is not available online? How can API 1 ensure that the request have reached API 2? We have to build some kind of a complex mechanism inside API 1, which can basically allow us to do all of the retry policies, and it's gonna allow us to keep a track of every single message, etc, etc. So we're gonna be doing a lot of overhead inside API 1 to make sure that API 2 receive the response. So that's the first thing. The second thing is we don't want to make API 1's responsibility to make sure that API 2 has received the message. What we want to do is once API 1 finishes its work, we want to delegate that responsibility to make the request to API 2 someone else's responsibility. So once API 1 has finished its work, we need to make sure that when API 2 needs to know, it's going to be someone else's responsibility to receive this info, to make sure that the information has been received successfully. And this is what we're going to be doing. We're going to be relying on events, which means that we're going to be relying on some kind of a messaging queue where basically once the first API have done something, we're going to be relying on a message, and then API 2 will pick up this message and will be able to continue the work. And this is basically where Service Bus comes into place. So within Service Bus, and basically within any event-driven architecture, what we're trying to do is really basically removing the HTTP response, we're removing the HTTP request, and basically we're replacing it with events. So we can think about it as a tube between the first API and the second API, and within this tube what we're doing is we're putting events, or we can call them messages. And whatever a new request has come in, what we do, instead of calling it directly, what we do is we just create a new message. Just put here a message. We can put a letter or basically a message here, and then basically it will be responsibility of that bus or the transportation layer to make sure that API 2 has received it. So what we're doing here is we're removing the responsibility from API 1 to manage all of the connectivity with API 2. All it needs to do is just put a message on the queue. So let's say I have 4 orders coming in, so I can have 4 messages coming in. And basically the API will put 4 messages on the queue for API 2 to pick up. So now that API 2 is actually running, now what API 2 will do, it will pick up every message and then it will actually execute it. So it will take it, execute it, and then remove it. Then these will move forward, etc, etc. Then for example, API 2 picked up another message. Once it picked it up, it will go here and it will stop executing for that message. Then again, the one afterwards, it will take that message, stop executing, pick it up, process it, and then removing it. And the last message as well, it will take it, process it, and then remove it. So this is what we're going to be doing. So basically what we're trying to do is we're trying to remove the direct HTTP by utilizing a service bus in order for us to make sure that the information is going from one point to another. So why do we want to utilize service bus? Why don't we want to use HTTP? So first of all, we said we don't want to have the responsibility for the communication relying on the API itself. We want to delegate it to something else. This is the first point. The second point is we want to basically monitor all of the calls. So if anything has failed, I don't want to build a very expensive overhead inside API 1. What I want to do is we want to handle all of this through the bus, or basically through that communication mechanism that exists between API 1 and API 2. I will have all of the events available for me. So let's say, again, I have my 4 events available on the bus, and basically API 2, for some reason, it's being updated and it went offline. It went offline for like a good 10 minutes. It can happen. So what happened to all of these requests? All of these requests will still be on the queue in order for them to be processed, and more requests will be sent, and more requests will be also on the queue, etc, etc. So in this case, once API 2 is basically start active again, it will start picking up those messages again. But as long as it's not active, the queue will be responsible for holding all of these messages. In case I don't have that, API 1 here, what's gonna do is gonna have to keep a state table or some kind of information about all of these different requests. It has to do all of the retry policy after a while. It has to do a backup implementation as well, so it doesn't want to keep calling it an API, etc., etc. So there's a lot of overhead that's kind of happening here. But by utilizing all of this inside a bus, I'm actually able to delegate all of this different overhead to the bus itself rather than having to build everything inside my API. And what we're also be gonna doing is I'm gonna have retry policy. So let's say for any reason this message, which API 2, so now let's say API 2 is actually up and running, and let's say this message went to API 2 and for any reason it wasn't able to send it. What it does, it will send it back to the queue saying I was not able to do so, and it will push some kind of an error. So that way I'm able to retry this message later on after I fix any types of error within my API, and it will be able to continue to resume. So here we can see I have automatically a retry policy that I can use rather than have to rely on API 1 to re-trigger everything all over again. So these are some of the main benefits of why we want to utilize events, and basically we're decoupling the communication between API 1 and API 2. We're basically letting all of these communication being served by a single queue, which is going to be responsible for moving the messages from the first API to the second. And what we're going to be doing today is, in order for us to build this queue, we're going to be utilizing Terraform in order for us to facilitate ourselves and have a clear understanding of all of the different configuration that's needed. It's not going to be much, it's going to be pretty straightforward, but it's always good to actually understand how it works from the code rather than the graphical user interface. So now that we have understood what are we going to building today, let's go to our Visual Studio Code and start building our infrastructure. If I go to Visual Studio Code here, inside my infrastructure file, I'm going to start first defining my setup for Terraform. And what I want to do here is I'm going to specify my Terraform configuration. So I'm going to put Terraform, and I'm going to specify the providers. I'm going to use Azure RM, and then I'm going to specify the provider who's giving me this access, which is going to be HashiCorp, which is the creator of Terraform. As well, I'm going to specify the version. So we'll put the source. It's going to be HashiCorp /Azure RM. And then I'm going to specify the version here, which is going to be equal to 3.86.0. You can use any recent version, it should be fine. So now that I have done that, the next step is I'm going to actually specify my features if I want to add anything to my current provider. So I put a provider, Azure RM, then I provide the feature list. Currently I don't have any specific feature that I want, so I'm just going to leave it empty. And the last thing I want to add here is going to be a resource group, and the resource group is basically how I combine all of my Azure resources together that I want to use inside a single application. So here I'm going to create basically a new resource group. So I'm going to put resource Azure RM underscore resource group, and I'm going to call it RJ. And this resource group is going to have a name. I'm going to call it SB demo das resource group, and it's going to have a location, and I'm going to use any location that's close to me. I'm going to use West Europe. Perfect. So now that I have created my resource group, now what I want to do is I'm going to start configuring my service bus. So I'm going to create a new file called servicebus.tf, and let us understand what we're going to be doing here. So if I go a bit down, so in order for us to use service bus, what we want to do is we need to define a namespace. So let's say I have between API 1 and API 2, I'm using this queue. But what happens if I have API 3 here, which API 1 also wants to communicate with? And what happens if I have API 4, which also API 2 wants to communicate with? So in this scenario, what I'm gonna doing is I'm gonna basically create another queue between API 1 and API 3, and I'm gonna also create another queue between API 2 and API 4. So we can see here now I have 3 queues inside my application. So I have a queue here, I'm gonna have a queue here, and I already have a queue here. So once I have all of these different queues, I need a way where to actually combine all of the queues that I'm using for my application inside the same section, if you wanna think about it that way. And this is where a namespace comes into place. A namespace is basically a way that tells me that all of these queues belong to the same application, as they're gonna be serving almost the same domain, or they're gonna fit into the same implementation that I need for my application. And this is where a namespace comes into place. So inside a namespace, I can provide as many queues that I want, and all of them will actually be, I know exactly, I have control over all of them. So in this scenario, when I'm in this example here on the left hand side, I have 3 queues. So inside my namespace, it's gonna be having 3 queues. For the demo application today, we're only gonna have 1 queue. So this is what we're gonna be creating, but I cannot create a queue without a namespace. So that's why first of all, I need to create a namespace, and then I can create a queue. So inside Terraform, I'm gonna put resource, I'm gonna put Azure RM underscore service bus, and as we can see, namespace is the first one. I'm gonna call it namespace, and then here I'm gonna provide it with a name, and this is gonna be sb-demo namespace, and then I need to find the resource group name, and this is gonna be the Azure RM resource group dot name, and then I need to specify the location, and also it's gonna be Azure RM service group dot location. Perfect. And lastly, I want to specify the SKU, which is basically what version of service bus that I want. And there is a basic, there is the standard, which I'm going to be using right now, and there's the enterprise. And in order for us to make our application simple, and we're not going to be going through enterprise, we're utilizing with the standard. You can also use the basic, but for now, we're going to be utilizing the standard. So now that we have created the namespace, the next step is we need to create the queues. So we'll put resource Azure RM underscore service bus underscore queue, and then I'm going to call this queue, and a queue pretty straightforward. It's going to take a name, and this name is going to be my queue. I can call it whatever I want, but we need to make sure that this is the same name that I'm referring to inside my application. And I'm going to be linking this queue to a namespace. So we can say namespace ID equal Azure RM service bus namespace dot ID. So this is all I need to do in order for me to have a service bus installed and basically up and running. I was able to first of all define this is all Terraform setup. This is the resource group that I'm going to be needing in order for all of my Azure code live together there. And this is where my service bus code actually is. So within I would say all in all 20 lines of code, everything is set up. So now what I want to do is I want to initialize this. So I put Terraform init, and this will basically initialize Terraform for me, just to take a few seconds. Okay, great. Now Terraform has been initialized. The next step is I want to do Terraform. Let's clear this up. I'm going to put Terraform plan, and this basically gives me a list of all of the different functionality it's going to be creating on Azure. Okay, great. We can see there's 3 items it's going to be adding. It's going to add my service bus queue, exactly what I want. It's going to be adding my service bus namespace, perfect. As well, it's going to be adding my resource group. Okay, great. So now what I'm going to do is I'm going to clear this up. I'm going to run this code. So I'm going to put Terraform apply. And now this basically should ask me, do you really want to implement those changes? I'm going to say yes. Then once I do that, it's going to create my queue and my namespace on Azure. So I'm going to say yes here. And now all of this is going to be basically implemented on Azure. So now Terraform is communicating with Azure to create all of these different resources for me. So let's give it a minute. Okay, great. So now it has finished successfully. We can see that 3 have been completed successfully. So now if I go to my web browser and I go to resource group, and then I go to demo.rj, and as you can see here, I'm going to zoom in a bit. I have my service bus demo. So if I click on that, and we can see this is my namespace that I have. And then if I click on queues, you'll be able to see that my queue that I just created is available for me. Okay, great. So now that I have these in place, now I can actually start using or basically creating my .NET code to communicate with this. So what I'm going to do is I'm going to go back to my terminal, and I'm going to go to my code, and I'm going to creating a .NET new web API dash controllers dash name. I'm going to call this my order API, and I'm going to create another API. Also, I'm going to make it as a controllers, and I'm going to call this email API. Okay, great. And what I'm going to do also, I'm going to be creating a class library in order for me to create my service bus code in one place and reuse them in these 2 web applications. So I'm going to put .NET new class library, give it a name of, let's say, service bus delivery. I can call it whatever I want. Great. So now that I have my 3 applications here, I have my first API, second API, and my service bus class library. I'm just going to create a solution file, and I'm going to call it. Okay, great. So now if I type ls, as you can see here, I have my solution file, I have my order API, my email API, as well as my service delivery. So what I'm going to do is I'm going to add those 3 applications to my SLN file, and we can do this through Rider. So I'm just going to open Rider right now. And now that I have opened my solution in Rider, all I'm going to be doing is add those existing projects. So I'm going to add first my email API. Okay, great. We can see it here. I'm going to add now the order API, and lastly I'm going to add my class library. Perfect. So now basically what I have here, I have my 3 applications. I have my email API, order API, and then my class library. Great. So the first thing that I want to do here is inside my order API, I want to clear out my controllers. So here we can see I have my weather forecast controller. I'm going to rename this to order API or order controller. So we can see here refactor. I'm going to say rename to order controller, orders controller, and click on next. And we changed it now. And then what I'm doing is I'm going to remove all of this. I don't really need this. Let's keep the logger. And this is going to be send email. And I'm going to leave it as get. and instead of returning a weather forecast, I'm just gonna make sure it's gonna be iAction result, and I'm gonna return here, okay, email sent, for example, which shouldn't implement anything yet, but now we're gonna add this functionality here. So now that my controllers are clean, what I wanna do is inside my service bus delivery, I'm gonna delete this class, and what I'm gonna do is I'm gonna create a new directory, and this directory I'm gonna call it Azure Service Bus. And inside here, what I wanna do is I'm gonna create a new interface. I'm gonna call this I Service Bus Queue, which is basically this is the main implementation. So here it's not gonna be a class, it's gonna be an interface. And here I'm gonna have two methods. One for me to send a message on the queue, and the other one is to receive. Okay, so let's start with the send. We're gonna return a task, and we're gonna say send message. And here what we have to do is we need to specify the queue name, and we need to specify the message itself that we're gonna be sending. Great. As for the receive, we're gonna be returning a task with string, and it's gonna be receive message. And here all we need to do is take the queue name to start receiving the message on that queue. Okay, perfect. So now that we created the interface, now what we want to do is we want to actually create the implementation for it. So we're going to put service bus queue. And what I want to do here is I'm going to first implement the interface, and we can see it start to complain. So let's fix this up. Great. So now this is running. We implemented it. We are missing a key piece here, which is going to be the NuGet package that Service Bus Delivery would utilize. So through my terminal, I'm going to go to Service Bus Delivery, and I'm going to install a package, which is going to be .NET add package Azure messaging service bus. Okay, perfect. Now it has been installed successfully. Now I can just check this out inside my CS Proj, and we can see it's installed successfully. Perfect. So now that I have this in place, now I can actually start building my class. And the first thing that I want to do is, because I'm relying on a dynamic connection string, I'm gonna put private read only string. I'm gonna call it connection, and this is gonna be my connection string. And using my constructor, I'm gonna initialize this. Perfect. So this is the first step. The second step here, for sending a message, I'm gonna delete this. We need to create a try catch block. In case something goes wrong, we need to be able to catch it. I'm gonna leave it with a simple implementation for now. So we're gonna create a service bus client. So service bus client equal new service bus client. And here what I want to do is I need to specify first my connection, and this is going to be what's going to be injected to my application. And then I need to specify my service bus options. And within these options here, what I want to do is I want to specify the type of mechanisms that I'm going to be using. So I'm going to specify the transport type, and the transport type is going to be either AMQTCP or WebSockets. I'm going to be relying on the WebSockets one. We're not going to be delving into a lot of details, but these are the different ways those messages can actually go into the queue. So now, once I created my client, now I want to actually send that message. So I'm going to put var sb sender equal sb client.create sender. And in order for me to create a sender, I need to pass the queue name, and this is going to be what's going to be provided here. And let's fix this sender. Great. Now that I have defined the sender, now I can actually send a message. I can put await sb sender dot send message async. And then here I need to specify a new service bus message, and this is going to be the message that has been provided. So we can see this is await, so I need to add here async. And now we can see this is actually all of the code that I need in order for me to send a message on that. Now, in order for me to receive a message, let's add this functionality here as well. We need to first of all put the try, and then what I'll do is I'm going to create a client. So var sb client equal new service bus client, and then here also I need to specify my connection, and then I need to specify my new service bus client options, and it's going to be the same thing on what type of connectivity or transport layer that I want, and this is going to be the same thing. So service bus transport type, I'm going to be running on the WebSockets. Perfect. So now that I have my clients, now I need to create my receiver. So I'm going to put var sb receiver equal sb client.create receiver, and I need to also specify here my queue name, so it's going to be also passed to it. And now once I have started basically initiate the receiver, I need to actually read that message. So I'm going to put var message equal await sb receiver dot receive messages, and here as you can see it's await, so I need to make sure this is async. And now we can see the return type is of type received bus messages. So what I want to do right now is I want to serialize this into actual text. So I'm going to put var message body equal encoding.utf8.get string, and we're gonna pass the message here. And within this message, I'm gonna use the body item. Okay, great. So now that I have this here, what I want to do is just gonna be simply returning the message body. Great. So this is how I receive my messages. I basically define a client, create a receiver, receive that message, serialize the body, and then return it. And for the sender, it's pretty straightforward. Create the client, create the sender, and then send the message. Great. So now that I have done all of the pipeline work or how I can actually use my service bus, now I'm gonna go to my order and I'm gonna inject those services here. So I'm gonna put builder.services.add singleton, and I have my iService bus queue. And now it's gonna tell me that it's not part of the project, so it will add the project and then add this. So let's do this right now. So yeah, I want to reference the class library and then use it. Perfect. So now I have this in place, but this is not enough, because if we take a look at the class here, we can see that we're injecting our connection string. So that's what we need to do. We need inside my order API to inject my connection string. So inside my app setting, I'm gonna be adding the following. I'm gonna be creating a connection strings section, and I'm gonna call this service bus connection. And what I'm gonna do right now, I'm just gonna get the connection string from Azure. So I'll go to shared access policy, click on this one, and we can see here on the right hand side, the connection string has been populated. I'm just gonna copy the first one, go back to Rider and add it here. Okay, great. Let's save this. And now what I want to do inside my program.cs, I want to inject that connection string. So I'm going to put here var sp connection equal builder.configuration.get connection string, and I'm going to give it the same name that I provided here, which is sp service bus connection. And now I have this in place. Now what I can do, I can use this service connection to inject this here and to do it. And the way to do so is pretty straightforward. I can put x equal new service bus queue and then provide the sp connection. And I can say if it's null, I can make it empty. It's not the best way to do so, but this is just the fastest way right now to provide this works. And now once this is all done, I can now go back to my orders controller. I can initialize this here, so I can put private read only iService bus queue. I'm gonna call it queue, and then I'm gonna initialize this through the constructor. Okay, great. Now I have my logger and I have my service bus connection. And what I want to do here is, first of all, I'm gonna make this async, and let's convert this to task. And what I'm gonna do right now is I'm just gonna send a message saying send email. So I'm gonna put await underscore queue dot send message, and now it's gonna ask me for my queue name. I'm just gonna call it based on whatever I have here. So if we go to my queues, my queue name here is called my queue. So I'm just gonna copy this and I'm gonna put it here, and it's gonna ask me now for the message that I would like to send. I'm gonna say send email to Mohamad at something like this. So now if I run this, a message is populated on my queue with this information. So let's try it out. I'm gonna run this. Okay, great. So now as we can see here, I have my orders, and what I'm gonna do is basically I'm just gonna go on try it out and click on execute, and we receive the 200 email sent. Now if I go to my service bus queue and I click on queue, and we can see we have some kind of activity. So if I refresh here, we can see I have one message available on the queue. And if I go back to my portal here and click on execute again and again and again and again, we can see here that still one, but if I refresh, I have 5 messages available on the queue for me to read. Let's add one more to make sure everything is working. Now it should be 6, so I'll click on refresh. We can see now I have 6 messages on the queue. Perfect. This is exactly what I want. And now we can see that this all is currently working as expected. So now what we need to do is we need to create the receiver part. So if I go back to Rider, I'm going to stop this. And as you can see here, I created them, and on purpose, I left them on the queue. They're not going to be going away, because basically once I start receiving them, they will live there until I start receiving them. If I go right now to email API, the first thing that I want to do is I'm going to add the same connection string that I have. And usually please put this inside the secret manager rather than hard coding it inside your app setting. But for now, to make it simple, we're doing this. So that's the first part. The second is I'm going to be also injecting this service bus services inside my program.cs. So I'm just going to copy this as is, and I'm going to put them inside my program.cs. Perfect. It's going to ask us to actually fix those references, and we're going to say yes, fix them please for us. And now we know if they exactly work. Okay, great. So now that I have this in place, this will not work here. Why? Because if I go back to my diagram, basically API 2, it will need to continue listening to it. So it's not going to be a one-time thing. So here, this is going to be like a let's say round arrow. So this will be something that's going to happen every single second, where basically the application will check, oh, is there a new thing? Is there a new thing? Is there a new thing? Is there a new message? Is there a new message? So API 2 will have to do like over and over, keep on checking the queue. Basically, it's going to be pulling those messages one at a time. And the way that I need to do this here is basically I need to create some kind of a background service, which is going to allow me to actually keep on pulling the information from my queue. And the way to do that is going to be the following. So inside my email API, I'm going to create a directory, call it background service. And I'm going to create a new service here. I'm going to create a new class. I'm going to call it Azure Service Bus Listener. Okay, great. And this will okay. And this will inherit from the background service class. And we can see here it's already asking us to implement the missing members, and this is going to be it. So before we implement it, I need to add certain stuff here, which is first of all going to be my implementation, or basically the iService Bus functionality that I created before. So I can add it by adding the following and the logger. I go private read only iLogger. Start with this one, Azure Service Bus Listener. I'm just gonna call it logger. I'm gonna add again a private read only Service Bus queue, and I'm gonna call it queue. Pretty straightforward. And then I'm gonna define my constructor, and I'm gonna initialize this through the constructor. Okay, great. So now that I have defined my main two items that I'm gonna be using inside this background services, which is my queue functionality and my logger, I'm gonna start building my execute async. So the first thing that I'm gonna be adding here is gonna be the logger. I'm gonna be logging information. I'm gonna say here listener started. Now what I want to do is I want to actually use my listener functionality. So I'm gonna remove this and I'm gonna add queue. Actually, let's make this as a wait queue, and let's make this async as well. So queue dot receive message, and it's gonna take the queue name, and the queue name is gonna be my queue. So let's verify this. It's gonna be called my queue. So let's copy this one here, and we can add it here. Perfect. And basically when we receive a message, we're gonna receive a string. So I'm gonna put var message equal, and just for simplicity's sake, I'm just gonna print out that message. So I'm gonna put console.writeLine, and I'm gonna print out my message. Okay, great. So this is all I'm gonna be doing. I'm just gonna listen to the queue, see if there's any messages, and then read whatever the message exists there. So now that I have added my background service, I need to configure my program.cs to actually utilize it, and let's see how we can add it. So after I inject my services, I'm gonna put builder.services.add hosted services, and this one is gonna be my Azure Service Bus Listener, and that's gonna be it. So now let's keep a very close look at the terminal once I start running it. So I'm gonna choose here my email API, and I'm gonna run it, and let's keep directly a close eye here. We don't really need Swagger for this right now. Okay, we can see there's some kind of an error, so let's see what this error is. Let's stop it and run it again. Okay, let's fix this error. So let's take a look at the configuration. I wonder what's going wrong. Let's stop this. And it's because I added in the wrong position. So let's just take this and let's add them on top. This is what happened when you record the video early morning, and now this should work. It was only about the position itself. So now let's keep a very close look at what's happening in the console. Now let's go back here. And as we can see here, I started receiving the messages. Sent email to Mohamad Lawan, and we can see the listener has already started here. So right now if I go back, we can see it only gets one, and that's because let's stop all of them, and that's because the way that we're actually receiving it, because once it does it one time it stops. So what we want to do is we want to create a loop, and the way we do that, say while not stopping token is cancellation request. So because we want to continue on listening not only one time, what we want to do is continue on listening whatever is happening. So I'm just going to take this and now putting this inside, and this should be able to make it work. So I'm gonna run my email service again, and let's keep an eye right now of what's gonna happen inside my terminal. And we can see here that listener started, and we can start seeing that all of the messages are coming through one after the other. So now if I go and run my orders again, actually let's change my request. I'm just gonna say, instead of saying send email, I'm just gonna say Mohamad at the beginning, so we can see it's a new message. And now I'm gonna run this, and now if I execute this, let's put this next to each other like this. I click on execute. we can see Mohamad has sent an email, and we can see it's almost instantaneously that we are getting those messages. So as soon as I click, we can see the messages being received. Okay, great. So this has been a very quick introduction of event-driven architecture within .NET, how we can utilize Service Bus to send events and messages through different services, how we can actually configure them, and how we can create a Service Bus within Terraform. I hope this video was helpful. If you have any questions, please make sure you put them in the comments down below. If you'd like to support me, please consider supporting me on Patreon or buying me a coffee. With that said, thank you very much for watching and have a great day.